This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on work. So a common physics concept is that of force, and a force can be thought of as a push or pull on an object. When a force displaces an object, we say that the force has done work, which is what we'll be studying in this podcast. If a constant force moves an object from point A to point B, then the work is just the force times the displacement, or the force times the distance, which in this case, since we move from point A to point B, is just B minus A. So for a constant force, calculating the work is actually quite simple, but it's pretty uncommon to have constant force over the entire interval. So we're going to study the idea of what happens when our force is actually can be represented as a continuous function over the interval. So suppose we have a continuous function, capital F of x, which represents the force on an object from point A to point B. So here's our example, and we want to calculate the work done over this interval. So if we want to calculate the work, we're going to approximate by dividing this interval up into smaller sections, and we'll label them x naught through xn. So somewhere in here we have xi minus 1 and x of I. And we'll consider, similar to when we were talking about the definition of an integral, this rectangle here. And to approximate the work done over this rectangle, we're going to approximate by saying that the force throughout that entire interval is equal to the force at the right endpoint. So for the interval xi minus 1 to xi, we'll just let the force be equal to x of I. So since we have approximated by saying there's a constant force, the work done over the interval x of I minus 1 to x of I is just going to be that force, so force x of I, times the displacement, which is just going to be the width of that rectangle, which we'll define to be delta x. So that's the work done over that ith interval. So if we want to sum the work done over the entire interval, we're going to say that the total work is approximately, at least, the sum from I equals 1 to n of f x of I times delta x. And if we then take the limit as n goes to infinity, we have the limit as n goes to infinity from I equals 1 to n of f of x of I, delta x, and that's actually equal to the limit from a to b, or the integral from a to b of f of x dx. So it turns out that our work is just equal to the integral from a to b of our force function over that interval.